Imagine a world of molten lava, a chaotic and hostile environment. That's where our journey begins with Proto-Earth. This ancient planet, our planet, was a dramatic spectacle of fire and fury. Its surface, a churning sea of magma, was constantly reshaped by the relentless volcanic activity. This was a world in the throes of creation, a newborn planet still forming its identity. The heat was intense, the pressure unimaginable, as the Earth's crust slowly began to solidify under the relentless onslaught of meteor impacts. The first few 100 million years of Earth's existence were marked by a period known as the Hadean Eon. Named after Hades, the ancient Greek god of the underworld, this era truly reflected a hellish landscape. But even in this inferno, the foundations for life were being laid. The heat and pressure deep within the Earth's interior were forging the elements necessary for the development of our planet's life-sustaining atmosphere and oceans. Then came the late heavy bombardment, a cataclysmic event that saw our young planet besieged by a torrent of asteroids. But even this violent chapter in Earth's history had a silver lining. One of these impacts, a colossal collision with a Mars-sized body named Theia, is believed to have given birth to our moon. The creation of the moon had a profound effect on Earth. Its gravitational pull helped stabilize our planet's tilt, leading to more predictable seasons and a climate conducive to life. In the face of constant change and violent upheaval, Proto-Earth was gradually transforming. Its molten surface cooled, oceans began to form, and the stage was set for the emergence of life. So from a fiery, chaotic mass, the Earth we call home began to take shape. This was the dawn of our world, a story of resilience and transformation, of chaos giving way to order. It's a story that continues to unfold, as we delve deeper into our planet's past and look forward to its future. While Earth was still in its fiery infancy, Mars, our red neighbor, was experiencing a more serene youth. This crimson planet, named after the Roman god of war, was anything but warlike in its early days. Instead, it was enveloped in a thick, warm atmosphere, a cloak of gases that shielded its surface from the harshness of space. This atmosphere was considerably denser than what we see today. It was a protective blanket, nurturing the planet and creating conditions conducive to the existence of liquid water. Yes, believe it or not, there was a time when Mars was not the dry, barren world we know today. Once upon a time, it was a planet where water freely flowed. Evidence of ancient rivers and vast oceans have been found on Mars. These aren't the creations of an imaginative mind but the deductions of scientists studying the planet's surface. Deep channels carved into the Martian landscape, patterns of erosion and sediment deposition, all hint at a time when water might have flowed on Mars. And where there's water, there's the potential for life. Could Mars have been a cradle for life billions of years ago? That's a question that has intrigued scientists for decades. While we have yet to find definitive proof of life on Mars, the possibility continues to tantalize us. Imagine, if you will, a young Mars. A world where rivers meandered across the surface, where a warm atmosphere buzzed with the potential for life. A world not unlike early Earth. It's a captivating idea, isn't it? And though Mars has since lost its warm atmosphere, becoming the cold and arid planet we know today, these early years of its existence offer exciting clues about its past. They remind us that even in the cold, silent expanse of space, planets change, evolve, and tell stories of their youth. Mars, a world that might have been more like our own than we can imagine. While Mars was nurturing the potential for life, Venus was becoming a hothouse. Venus, our neighboring planet, was once a world of vast potential, perhaps even resembling early Earth in many ways. But as time went on, Venus underwent a catastrophic transformation. Its once welcoming environment became a hothouse of extreme temperatures, a testament to the awesome and terrifying power of the greenhouse effect. The term greenhouse effect might ring a bell from Earth's climate discussions, but on Venus, it was taken to an entirely different level. This process, which occurs when a planet's atmosphere traps heat from the sun, ran wild on Venus. The planet's thick blanket of carbon dioxide and clouds of sulfuric acid created a potent thermal trap, locking in the sun's heat and causing temperatures to skyrocket. Imagine a world where the temperature is hot enough to melt lead, where the atmospheric pressure is akin to being half a mile underwater on Earth. That's Venus, a world where the surface temperature averages around 860 degrees Fahrenheit, hotter than the surface of Mercury, the planet closest to the sun. But how did this transformation occur? Scientists believe Venus may have once had liquid water on its surface, much like Earth, However, as the sun grew hotter over billions of years, the oceans evaporated, releasing vast amounts of water vapor, a potent greenhouse gas, into the atmosphere. This set off a chain reaction of runaway warming, transforming Venus into the scorching world we know today. Yet, Venus serves as more than just a fascinating case study in planetary science. It's a stark reminder of the power of the greenhouse effect, a cautionary tale of what can happen when a planet's delicate balance is tipped too far. Venus, a stark reminder of the power of the greenhouse effect. Traveling farther from the sun, we encounter the gas giants, Jupiter and Saturn. In the early days of the solar system, these enormous planets were just beginning to take shape, their formation a spectacle of cosmic proportions. The infant Jupiter and Saturn were shrouded in a thick cocoon of gas and dust. These swirling clouds were remnants of the solar nebula, the primordial soup from which the planets were born. Over time, the gravitational pull of these nascent planets slowly drew in these materials, layering them into vast, dense atmospheres. Imagine Jupiter, the largest planet in our solar system, in its early stages. The planet's immense gravity drew in copious amounts of gas and dust, creating a dense, turbulent atmosphere. Jupiter's powerful magnetic field, the strongest in the solar system, was also beginning to form, a direct result of its rapid rotation and the movement of conducting materials within its interior. Not too far off, Saturn was undergoing a similar transformation. Though smaller than Jupiter, Saturn's atmospheric composition was remarkably similar. Rich in hydrogen and helium, the planet's atmosphere was also interspersed with traces of methane, ammonia, and water vapor. The early atmospheres of these gas giants were not static but dynamic, ever-changing landscapes. Storms of unimaginable scale raged across their surfaces. Jupiter's Great Red Spot, a storm larger than Earth itself, may have been born during this tumultuous period. But it wasn't just about atmospheres. Both Jupiter and Saturn began to amass their iconic systems of rings and moons. These celestial bodies, some as large as planets themselves, were likely captured by the planet's mighty gravitational pulls, becoming permanent residents of their orbits. As we delve into the depths of the past, we see Jupiter and Saturn not as they appear today but as colossal figures in the early solar system. They are testament to the dynamic, often violent processes that shaped our cosmic neighborhood billions of years ago. Jupiter and Saturn, colossal figures in the early solar system. Even farther out, we find the ice giants, Uranus and Neptune. These distant worlds, often overshadowed by their gas giant siblings, hold unique mysteries of their own. Born in the frigid outskirts of the solar system, Uranus and Neptune are aptly named the ice giants. But don't let the name fool you. These planets are not massive balls of ice, but rather, they are composed of a rocky core surrounded by a thick slush of water, methane, and ammonia ices. The formation of these planets is a tale of slow growth and eventual stagnation. Unlike the gas giants, whose formation was a rapid accumulation of hydrogen and helium, the ice giants had a different path. They started out as rocky cores, much like their terrestrial counterparts. However, as they grew and moved farther from the sun, they began to accumulate ices, volatile compounds that were abundant in the colder regions of the solar system. This accumulation was a slow process, taking hundreds of millions of years. The growth of these icy behemoths was eventually halted, not by a lack of material, but by the dispersal of the solar nebula. As the nebula thinned out, the supply of ice and gas dwindled, leaving Uranus and Neptune as the smaller siblings among the giants. Their unique atmospheres, rich in methane, lend these planets their distinct bluish color. The methane absorbs red light from the sun and reflects back the blue, painting these planets in hues that are truly otherworldly. Deep within these atmospheres, pressures and temperatures rise, creating extreme environments where strange phenomena occur. It's here in these depths that diamonds may rain down, formed from the immense pressure acting on carbon atoms. Uranus and Neptune, the distant icy sentinels of our solar system. Their formation, their composition, and their unique atmospheres offer us a glimpse into the cold, outer reaches of our cosmic neighborhood. As we continue to explore these ancient planets, we unlock more secrets about the early days of our solar system and its dynamic history.